Hey guys, Mr. Gran for day 2 of transformation. So now we're going to focus on reflections, this part, and horizontal stretches and compressions, that part. So here we go. All right, we already covered this in the last video. We covered horizontal translations and vertical translations, reflections. A reflection across the x-axis is a vertical reflection. So to reflect something, you're multiplying it by a -1, by putting a minus sign in front of it, right? That's going to make something that was normally oriented like this flip to the opposite. If that negative sign is on the outside, that is a vertical. Just like yesterday, it's a vertical visitor. But it's also a reflection across the x-axis. Now, a lot of students get confused by that, and here is how I show it. If we have an xy axis, right, x is the horizontal one. If I have a point up here and I reflect it across the x-axis, it's now going across the x-axis to here. Well, that's a vertical movement, so that's a vertical reflection. Across the y-axis, if it's a negative on the inside of the parentheses, that is now in the home, so it's a horizontal, homie. So that is a horizontal reflection. And the reason we put it that way is because you can see it both ways on like an MCA or an ACT test. All right, so horizontal across the y-axis, similar reasoning. If I start with my point here, I flip it across the y-axis, it's moving horizontally to get from there to there. All right, what's next on here? Yesterday we talked about vertical compressions and stretches in the last video. Today we're using horizontal ones. So with shifts, translations, if you were doing a vertical, plus was up, minus was down, which was sort of logical. And then if it was on the inside, if it was horizontal, minus was going to move it to the right and plus was going to move it to the left because it's sort of opposite of what you would think. Same thing with horizontal stretches and compressions. If this number you're multiplying by is greater than 1, it is a horizontal compression. And we could say it's a horizontal compression of 1 over a, the reciprocal of it. Same thing with the horizontal stretch. If this is a number that's less than 1, so like 1/2 or something like that, that's actually going to stretch it by a factor of 2. So same thing, it's a horizontal compression or a stretch, and we take the reciprocal as the verbal description of it. All right, so taking a look at this, describing these transformations. I'm going from x squared as my parent function to now negative x squared, no parentheses here, so it's vertical. This is going to be a vertical reflection. VREF, again, abbreviate as much as you feel is necessary. Now we're multiplying on the inside, we're in the home, so horizontal homie. This is going to be a horizontal compression of 1/3. So it's going to get 1/3 the size horizontally. It's going to squeeze in by a factor of 3. So horizontal compression of 1/3. Now we've got, again on the inside, this is a horizontal stretch, not of 1/2, but of its reciprocal, 2 over 1, or just 2. All right, our next one. This is a number 2/3 that's less than 1, so that means that this is a horizontal stretch. We can use HS from here on out. And the reciprocal, 3 over 2. Now I've got a couple of doubles here. I've got a negative on the inside here. This is not a horizontal compression of -2/3. This is two things, a horizontal reflection, because of that minus that's on the inside, and a horizontal compression of 2/3, the reciprocal. And then our last one, again, not a horizontal stretch of -2, it's a horizontal reflection and a horizontal stretch of the reciprocal of 1/2, which is 2/1, or just 2. All right, so now going the other direction. Starting with the verbal description and rewriting the equation. Taking x squared, we want to compress it horizontally by a factor of 1/4. That is going to mean that we have to multiply by the reciprocal on the inside. So we're flipping that 1/4 to a 4/1. So 4x in parentheses and the squared on the outside. That tells me that's going to tell me this is a horizontal compression, not a vertical stretch. All right, stretched horizontally by a factor of 8. Now we're going to, again, put it on the inside of the parentheses and flip that to a 1/8. Compressed horizontally by a factor of 1/3 and reflected over the x-axis. So compressing horizontally by a factor of 1/3, that is multiplying by the reciprocal on the inside of the parenthesis. Reflecting over the x-axis was a vertical, and so that is a minus on the outside of the parentheses. All right, a few more slides. Describing the transformation with a square root instead. So now we're starting to mix and match horizontal and vertical. So square root of x going to 3 times the square root of x. That's going to be a vertical stretch of 3. This 1/2 is inside the grouping symbol. So not necessarily parentheses, but the grouping symbol, which is the square root symbol. Multiplying by 1/2 on the inside, it's horizontal, it's a homie. Multiplying by 1/2 makes a horizontal stretch of 2. Another 2 over here. We're multiplying by a -4. This isn't a vertical stretch of -4. It's a vertical reflection and a vertical stretch of 4. So that one would get flipped over and stretched out. Multiplying on the inside is a horizontal homie. Multiplying by a number greater than 1 makes a compression of its reciprocal. Another 2. 1/3 on the outside multiplying makes a vertical compression of 1/3. Multiplying on the inside is horizontal. Now it's opposite, so multiplying by a 2 compresses by a factor of 1/2. And then our last one, just one on this one. A negative on the inside means that it's a horizontal reflection. All right, 2 more slides. So now just some slightly more complicated problems where we're converting from verbal description to the equation. Stretched vertically by a factor of 5 and translated up 3. So that means we're multiplying by 5 on the outside, and up 3 is adding 3 on the outside. Compressed horizontally by a factor of 3 and reflected over the x-axis. Compressed by a factor of 3 is multiplying by 1/3 on the inside. And then reflected over the x-axis is a vertical, so a minus on the outside. Compressed vertically by a factor of 1/2 and translated right 2. Oh, I actually made a mistake there. That should be by a factor of 3. So that's a little trick to this one, is sometimes the verbal description, we could really make it compressed by a factor of 1/3 there. That's how I would usually describe it, but it's kind of one of those things where it can be written either way verbally, and and then you get tricked like that. It happened to me, so it could certainly happen to you. And I had already practiced this and made the key for it. Okay, so compressed vertically by a factor of 1/2. That means there's a 1/2 on the outside. And then translated right to move something to the right, you have to subtract on the inside of the grouping symbol, like that. All right, last slide. I think these are the same things as the one from yesterday, except now with the square root symbols. So left 2 and right 5. I think we said that wound up being a right 3, so x plus 2 minus 5, and that would reduce or simplify to just a minus 3. And again, I don't think we're going to have ones where you have to simplify after that on the test. Reflected over the x-axis and stretched vertically by a factor of 8. X-axis is vertical, so a negative on the outside, and then stretching vertically by 8 would also be multiplying on the outside. So negative 8 times the square root of x. Compressed horizontally by a factor of 3, we could really also change this to 1/3. So 3x, and then translated up 1 is a plus 1 on the outside. All right, so again, questions on any of this stuff, email your teacher, and like I say, we'll get through this, and eventually we'll start using this when we get into the later chapters of this class.